Hello everybody, today we're going to be looking at the final example for chapter 2. It's in 2.7, solving problems involving more than one right triangle. So in this question we're going to be solving a problem with triangles in different planes. So it says from the top of a 90-foot observation tower. So the towers here, they give you this diagram in the book. So I'm taking this and writing it down just in the lines without the picture, adding in the 90 degrees and the angles that we need. It says there's an angle of depression of 5 degrees, so there's your horizontal if you wish. So if that angle in here is 5 degrees, that means the right angle triangle it makes is going to be 85 degrees. And another fire due south, there's the south. So when something's due west and due south, that means it creates a 90 degrees there as well. Okay, as you can see here, you got to try to see it in 3 dimensions. That has an angle of depression of 2 degrees, which would give the inside right angle triangle an angle of 88 degrees. Okay? It says how far apart are the two. So what we need to do is we want to find the distance from the west fire to the south fire. So what we'll need is to get the length from T to W. We'll have to get the length from T to S, and then you guessed it, do the Pythagorean theorem to get WS. So that's what we're going to do here today. So the first thing we're going to do is I'll pick the triangle, we'll look at triangle RTW. And what we're going to do is we're going to find this distance here. So we know we have, with respect to 85 degrees, we have the adjacent side, we're looking for the opposite. So that means we're going to need the tan ratio. Okay? So let's fill in what we know. So we'll use the tan ratio, we'll do RTW first. So that means we have 85 degrees. Sorry, we're going to put 85 degrees in here, insert 85 and the degree symbol. Opposite is TW, that's what we're looking for, opposite of 85. And the adjacent to 85 is RT, which we know is given by 90 feet. So that means that TW, and we're going to multiply both sides by numbers, so TW is equal to 90 tan 85. I always put the number that you're multiplying in front of the tan, because if you put it at the back here after the 85, you may think that you're going to put that in there in your calculator, right? So in case, if you didn't put the brackets in, it'd mess up a little bit, right? So we got to be careful there. And when we calculate that, we get 9 10 85, and you get 128 or 1,000. Sorry, 28. Oops, 1,028. So when I punch it in my calculator, I get 1,028.7047, so on. Okay, you're going to leave that in your calculator, all right? Now we're going to do the exact same thing on the other side, only this time we're going to be using 88 degrees, all right? So everything is literally going to be completed again, only this time with the 88 degrees, all right? So now we're looking at RTS, all right, or RST, whatever way you want to look at it. Okay, so that's going to be 88 degrees this time. You're still 90, right? And that's not going to be TW you're looking for. You're looking for TS this time. All right, TS or ST doesn't make a difference. All right. Okay, I'll steal this again because it's, remember, we're pretty much doing the same calculation as we did last time, only changing the numbers. So we're looking for TS this time, and the angle's 88. So that means that TS is going to equal to 90 tan 88, which incredible difference. You'd be like, is that something I put wrong on my calculator? No, it's not. It's 2,577 decimal 262,795, and so on. All right. So now we have the length from T to S. We have the length from TW and length from T to S. So now we got to find WS, so we simply use the Pythagorean theorem. Alright, so equals plus, so there's a Pythagorean theorem. We'll fill in what we know. Remember, it's going to be WS is the hypotenuse, so it's WS or SW squared is equal to TW squared plus TS squared, right? That's the Pythagorean theorem. The hypotenuse equal to each of the other sides squared and added together, right? So let's fill in what we know. So we'll recopy this formula down. Filling in what we know. WS is what we're looking for. TW is this number right here. So remember, you're going to use that number. It's in your calculator. That's what I recommend. Alright. And then take this number here. And again, it's in your calculator. Alright. Your calculator. So I'm going to square this. And square that, and we get, when you square those two together, you get, so I'm just squaring them and adding them, you get 7,516,892, and so on. And then we got to take the square root of both sides. Alright. So WS is going to equal to the square root of that. Radical sign, square root of that number. Again, that number's still in my calculator, right? Okay. So I'm just taking the square root of the number that's in my calculator. And I get WS equal to 2,774.980,521, and so on. Alright, so our answer says how far to the nearest foot, so the decimal 9 rounds the 4 up to a 5, so 2,775 feet. And you want to answer the sentence, how far apart are the fires? Right? How far apart are the fires? So let's say the fires are 2,775 are approximately, because we did round, approximately 2,775 feet of fires. And that is it for the chapter. Okay, so there's a check your understanding question I'd like you to approach. It's very similar, and also there's questions that are going to pertain. You'll get some more questions too. I'll present them to you in class. But there's your homework questions that come along with the questions for 2.7. It's page 118, numbers 4 to 6 and 8 to 14. And again, there's going to be some questions at the end of the chapter 2 that we're going to look at. So that's it for chapter 2. Thanks for watching the videos. I hope these help, and we'll talk again soon when we start chapter 3. Thank you.